Hello guys, it's Dr. AJ. So today we have three examples on consolidation. Very important topic in the FEMP exam. You're always going to get questions on consolidation. So let's get started. The first example, as you can see, we have a normally consolidated soil. Initial stress of that soil basically is 3000 psf. The vertical stress increased by 500 psf due to sand fault placement. The liquid limit is given 55. What is the change in void ratio? So that's all the example. So in order to find E, we have C sub C, which is the compression index. The compression index is basically the relationship between the change in void ratio and the change in stresses, the log of stresses. So delta E is what we're looking for. The change of stresses, we have the stress, the initial one, and we have the change in that stress. So we can find this part. C sub C, we still don't know how to find this one. This is basically how it looks like in your reference manual, but there will be a different equation. As you can see, there is a different equation for C sub C, but this one is based on the liquid limit. Do we have the liquid limit? Yes. So the C sub C 0.405, and then now we can find the stresses. Initial stress is 3000 psf. The change of stress is basically initial plus what is added, which is the 500. So it's going to give us 3500 psf. So now is if we want to put it mathematically, it'll be C sub C equal delta E of log the additional of stress, which is the P naught plus delta P minus the initial, which is P1. We all know in load, basically, if there is a subtraction, we can make it with one log and put a division. So C sub C, we just find that based on the liquid limit, it's 0.405. The log of 3,500 over 3,000, and that's going to give us delta E of 0.027, and that is option C. Example 2. So we have a normally consolidated clay layer. They applied some stresses on that layer, so it went from initial stress of 2000 to 3000 psf. Compression index is given 0.45, and initial void ratio is given as well 0.75. What is the settlement of that layer? And the answers should be in inches. Clay layer thickness 10 foot is given, compression index is given, the initial void ratio is given. So we're looking for the settlement delta H. This is basically the equation in your reference manual. It is based on C sub C, the compression index. Since it is normally consolidated soil, we're going to be using this equation. Delta H is what we're looking for. This is the equation. By the way, we have a normally consolidated soil, and so this equation should be used for that. What's the difference between normally consolidated and over consolidated? Normally is basically the soil. This is the highest stress has ever been experienced by the soil. When we say over consolidated, it means the soil at some point in life in the past has experienced some stresses higher than what is experienced currently. So H naught is given is the thickness of the clay layer. C sub C is given 0.45. E naught is given 0.75. And then we have the change in stress, the total one, which is 3000, and the initial stress of 2000. So this is basically P naught. This is the P naught plus delta P. We just apply. You can use really, this is just another form. Like it's easier sometimes to put P2 over P1. H naught is 10 foot. If you want to convert it, you can convert it. If not, it's okay. Really, you will get the results in foot, and then you can convert that to inches to get the result. So 1.75, this is the void ratio, and 0.45, the C sub C, 3000 over 2000, the log for them, and that's going to give us 5.433 inches. So it is option D. And if you go to the page 261 for your reference manual, you're going to see this equation, and this is for normally consolidated soil. First of all, you will see just the term C sub C. You're not going to see the compression range factor, C sub R, and it does make sense because we said normally consolidated soil. That means the soil is experiencing the highest stresses ever. So P naught has to be greater than the P post, and P naught plus delta P has to be greater as well than P positive. So that's why we're using this equation. It's in your reference manual, version 10, page 261. And by the way, in the same page, you're going to see the C sub C, the one we just used in example 1. You see, this is the equation based on the liquid limit, and this one is based on the change in void ratio and the change of stresses. Example 3. So we have clay layer, saturated actually, and then they added some sandfall on top. C sub C and void ratio is given. Specimen was taken from the middle of the sample, and we want to know the consolidation settlement after placing the sandfall, the 5-foot sandfall, and its density is given as well. So we're looking for a settlement. This is basically the equation. We used it before in example 2. We're looking for delta H. H naught, we have that. E naught, we have it. C sub C, we have it. We just need the stresses. So let's start by finding stresses. First of all, let's find the P naught, which is basically the stresses of the soil without the sandfall. This is the initial. So it's basically gamma H. But what gamma? This is very important. It has to be the effective stresses. So since this is saturated, so we need to subtract that from gamma water, 62.4 PCF. And then we will face the height issue. So please pay attention. They took the sample from the middle of the layer. So it's 7.5 feet. And that's going to give us initial stress of 94.5 PSF. And then we're going to go ahead and find the change of that stress, which is basically the P naught, the 94.5 plus the addition of the sandfall layer, which is just basically 5 times the density 125, and that's going to give us a total P naught plus delta P of 719.5 PSF. So now we can just basically plug and check to get the settlement. So H naught will be 15. Why? Because it's the whole layer is experiencing the settlement. It has nothing to do with where they took the sample from. So 1 plus E naught is 0.9, C sub C given 0.5. We just find the stresses, and that's going to give us 3.48, and the option is basically option A. So with that, thank you very much, and we'll see you next time. Oh, by the way, if you like the video, please don't forget to hit like and subscribe. Thank you.